Hello Flat Earth researchers, debaters and debunkers. I've been prompted by a Flat Earth debunker to demonstrate something which I did many times when first contemplating the Flat Earth and how we see the sun, moon and stars go above our heads, and comparing that with the ball Earth model. And it's for this reason with fans and other things that spin that made me arrive at the conclusion that what we see above our heads is the result of being on a flat Earth. So let's just take a look at how that can be worked out. So if we just take a look at this scene from a distance, we have the dogs, they would be lying around the edge of the flat Earth, and we have that black ring in the center representing the North Pole on the Earth, and above that we have the center of the fan representing Polaris, and you can see that I've put a disc on one of the fan blades to represent the sun or the moon. So if I was standing at the North Pole of the flat Earth, in the center of the flat Earth, then I would look up, and directly above my head should be Polaris, the center of the fan. And then I would look down a little bit to see the sun, this white disc stuck to the fan, coming across the sky from the east to the west. Okay, just take that back a bit, put it there. So what I can do now is walk over here to where, let's say this is the equator, and I'm now I'm facing east, okay? And I look up, and here we see that the fan blades are going to come directly over my head. So the sun or the moon, they both follow the same path, come along. Remember, this is east, so they come along in the eastern sky, and it's going to come over my head. And here is the point where the sun or the moon is at its zenith if you are standing on the equator, and as it carries on, you're going to have to lean backwards to keep tracking the sun or the moon. So you can see here that this coin represents either a sunspot or a marking on the moon. So as I'm facing east and the sun or moon comes over, this marking is apparently on the top of the moon or sun that I'm looking at. As it goes overhead, I'm going to have to turn around, and now I'm effectively facing west, and I'm watching the sun or the moon go off down to the western horizon. And of course that spot or marking on the sun or the moon is now on the underside. Yeah, if I just take it backwards, it's above my head. Here's the point where I've got to turn around and watch it. Okay, so here it is again. It would come at me from the east. I'm facing east, marking on the top. It goes over my head. I've got to turn around to watch it going away from me off to the west, and away it goes, and the marking is now on the bottom. So now I'm watching from further down south of the flat Earth. I've gone beyond the equator, so now I've got to angle down slightly. The moon or the sun at its zenith will not be directly overhead. It will be some degrees lower than 90 degrees. Okay, so I'm going to, same thing, I'm heading east. The heading of my view is east, and I'm going to watch the sun come across the sky. There it is at its zenith, and I follow it off to the west. Okay. The dog's seen all this before, not impressed anymore. Let's have a look now at how this would affect star trails. So I'm looking up at the stars or the sky as if I'm somewhere north of the equator, not quite up to the North Pole, and just take a note of the direction that the blades appear to be turning from left to right. They're going across from the left to the right of the screen. Okay, now I'll just give this another spin and I'll step over here as if I'm crossing the equator and turning around and facing back north. I'm now south of the equator, and you can see that the fan blades appear to be going from the right to the left. They haven't changed their direction of spin, but I've changed my orientation to look at it. Okay, go back under and turn around, and now the blades are going from left to right again. You see, north of the equator, left to right, south of the equator, right to left. Thank you very much.